Good day! Today, we will be executing fieldwork number 6, which is the trigonometric leveling. Our objectives for this fieldwork are: number 1, to acquire and develop the skills of determining the vertical distance or the elevation and height of a remote point by applying trigonometric and related analysis. And number 2, to develop the skills of reading vertical angles using theodolite or the total station. The instruments and accessories to be used are theodolite, leveling rod, markers which can be chalk or marking pins, measuring tape, plumb bob, and range pole. For the procedure, the first thing that we'll do is to set up the theodolite at a convenient location. Then the location where the leveling rod and the remote point are visible will be called point A. Using the telescope, take sight at the topmost remote point, then read the vertical angle and record as alpha on the table. For the second trial, take another sight on the telescope. This will be done to determine the precision of the observations done.
Calculate the mean of the two vertical angles or the angle of elevation, not the zenith angle, of the specified point from the first station. Then set the leveling staff or rod vertically near the base of the remote point and take the level foresight on the rod to determine the height of the instrument. Transfer the theodolite towards the location of the remote point and designated it to station B. Then measure its distance by taping from station A and record this as distance AD. After centering the bubble of the instrument level, sight at the same topmost remote point or the sight before, twice using the telescope, and record as B or beta on the table. After recording these two observations of vertical angle, calculate the mean. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point.
To better understand fieldwork number 6 trigonometric leveling, let's analyze this figure below. See how right triangles are formed to determine the height of the remote point. Note that this fieldwork will not consider the effects of combined correction of Earth's curvature and refraction. To determine the difference in elevation between two instrument setups, we will use this formula. We will consider triangle BEF and solve for the distance x using the tangent function. After this, we will determine the sum of distance AB and distance x for the analysis of oblique triangle AFD. Now, we'll consider triangle AFD and use sine law to determine the distance FD. Lastly, to determine the height of the remote point DG, we will consider triangle FDG. After all the computations, input the gathered and calculated data on the table.
Thank you.